Welcome to the Boots on the Ground podcast, the podcast where we explore how ERP transforms operations, streamlines production, and delivers real results in manufacturing. Whether you're running a plant, leading IT, or just trying to make sense of digital transformation, this is where tech meets torque. Let's get into it. Manufacturers have invested heavily in ERP systems, CAD platforms, automation, dashboards, and digital transformation initiatives. But one of the most important handoffs in the entire manufacturing process is still one of the most overlooked, the handoff between engineering and ERP. That gap affects almost everything downstream. When BOMs are entered manually, engineering data has to be cleaned up by hand, or teams rely on spreadsheets to connect designs with execution. The entire operation feels all of this pain. Purchasing, planning, production, and ultimately the customer are all impacted. Today, we're talking about why that gap still exists, what it costs manufacturers, and how companies can connect engineering data to ERP in a way that is accurate, scalable, and built for the real world. And to have that conversation, we were joined by someone who's been focused on that very problem for some time. Our guest today is Scott Brickler. As the founder and CEO of CADTALK, Scott has spent years helping manufacturers bridge the gap between CAD and ERP systems, turning engineering data into manufacturing-ready information that the rest of the business can actually use. So today, we're going to get his perspective on why this problem has lasted so long, what manufacturers often misunderstand about integration, and what the future looks like as engineering, ERP, automation, and AI continue to come together. Scott, welcome to Boots on the Ground.
Oh, happy to be here. Super excited.
Yeah. Awesome. So how'd you get into this engineering, ERP, and manufacturing technology space?
You'll probably love this. It's because I started out as a Sightline user, actually at a packaging company here in close to Cincinnati in northern Kentucky. And I actually had to work as a manufacturing engineer doing routings and taking designs and essentially creating bills of material and routings and all of that inside of Sightline at that day. And I couldn't figure out why engineers designed everything in a computer system and then printed out drawings and handed it to a bunch of guys, manufacturing engineers, and who didn't turn around and looked at the drawings and typed it back into a computer system. And and at the time there was 250 design engineers who were just cranking out 3,000 new part numbers and 3,000 engineering changes a month. And there was 8 full-time people just doing that. And they weren't just doing they weren't just typing things into Sightline. They were actually looking at the designs and figuring out what machines need to be made and what the run times were and all of that. But there was a lot of their time just literally creating things manually in the system.
Yeah, right. So yeah, it's for our listeners, it's like the bill of manufacturing, the BOM. Some people call it bill of manufacturing, bill of materials, two different things, but materials are part of the bill of manufacturing. That's what you get from the drawing. Yeah. It's the other stuff that the manufacturing engineers have to make the interpretations, and that's what you're referring to, right?
Yeah. Okay. And it was if you didn't know the machine, I remember I was a co-op at the time too, so I wasn't our intern, which and I hated I hated doing the job because I didn't know enough about manufacturing to be able to do the routing. So what they did was they would a lot of times the senior guys would just write down on the drawing what the stuff was, and then they'd make us type it all in. That's usually how it worked. So it was kind of a job I didn't really like. So I was can we automate this? And so the idea for this is probably late 90s that we'd actually had the idea.
Yeah, so that's the real problem that led to CADTALK, right? That's the stuff we have today, right? Okay.
Absolutely. And then the first version of CADTALK didn't come around until 7 or 8 years later. It was just technology wasn't where it needed to be quite yet, and then things like that. But it was but when it finally came around, we ended up creating it, and I said it works really well. But
it's pretty awesome. So I've seen it at work. So why is engineering to ERP integration still such a problem for manufacturers today?
Yeah, it's if you think about it, and I mean obviously there's people they really focus on the time, right? The time aspect of it, that like I talked about earlier, is there's 8 people trying to do this and try to do this transformation, but if you think about for a manufacturing company, the bill of material is super important. I mean, it's just the kind of the foundational data of how ERP works, right? It's we used to have these ads we put out years ago that was Sightline doesn't work without a BOM, which is I mean, it's kind of true, right? I mean, you really can't do much, you know,
Yeah, you don't know
without
what to
it.
buy, you don't know what to make. Yeah.
Yeah. So if you think about it, if everything you buy this, really awesome ERP system, but you feed it, nothing to work with, it doesn't work very well. And so a lot of companies want to do scheduling, they want to do planning, they want to do all these things with these tools, but they put it on flimsy data, which is usually the bills of material. Then it tend to work really well. I mean, we
Right.
talk about companies wanting to do finance scheduling all the time, and they just, without routings and without runtimes, you can't even talk about that, right? I mean, this is the foundational data. And so really, I think that's the core thing. It's like, I always think about it as actually, how do we make the tools that you already own more useful, and how do we make that foundational data more accurate, and then also how do we make it easier? Because like, if we had friction along the way, or we had like a human element on the way, it deteriorates.
Right.
So a lot of times we work with a lot of ETO companies, and the lead time between when the engineer thinks of something and it actually gets made is a super huge component of that. And if it's waiting for someone to decide how to make it, they also lose that lead time tends to increase. So there's two things: quality of the bills and the lead time reduction from the engineer's mind to the actual shop floor is what we try to work on. Yeah.
Perfect. Yeah, it'd be very helpful. So I kind of got a two-part question for you here. Then it kind of leads me to say, it's obviously a problem for manufacturers, and not everybody sees it. And as they're, people are at different places in their maturity journey. As a manufacturer utilizing ERP and leveraging ERP, we talk about it on the scheduling side and advanced planning and scheduling versus MRP, right? So when are we ready? When do we mature enough? When do we have the right bombs? So we're in the right place here. But from your experience, at what point does a company usually realize that it's not just an inconvenience, but a systemic problem? And then along with that question, we'll pull the ask questions in the briefing room. I'll do two questions. Is the problem usually visible to leadership, or is it hidden and has to be surfaced?
Yeah, it's like, I think it is. I mean, to answer the first question, which is like, well, when do they realize it? Typically, people see it when they have a lot of engineering. We call it a lot of engineering turnover. Like I mentioned earlier, with the company that I came from, they were an ETO, engineer to order type of company, and they're generating just ungodly amounts of new design. Right? If you have 250 engineers, they're doing stuff all day. They're making, right. So you typically see this pain of like, hey, this customer wants this thing, I need to ship, and then you're like, okay, I got the new design out, and then they're like, okay, are we making it? And the guy goes, no, it has to go through this and this and this and this, and then we can make it. And then the guy, then leadership starts to see it, and then it ends up being like, well, why do we have to go through all this? And then it becomes like, it escalates as a problem, and that's when it becomes more visible. Now, because it's very apparent, you're holding up money, which leadership pays attention to. The subtle things where it gets harder for leadership to do it is when it's the silent kind of drift that you have with your systems. It's like, why isn't our ERP working well? Why is it not doing this right? It's the slow drift because those bills aren't quite right, or that the engineer isn't designing their system. They're not following any standards. So like, they're not able to figure out what needs to go in the right place, or these things aren't being engineered. So we find a lot of times like engineering standards, as well as they also flow down. If those standards aren't done well, it flows downstream into the ERP and causes more issues. And I mean, I know you've been through it. I've seen ERPs get thrown out because the data was bad.
Yeah, for sure. Yeah, that's great. And that leads us actually right into the next. It's almost like you got these questions beforehand or something. But
I was really good at winging it.
You set me up real good, man. So I know that CADTALK definitely saves time and it saves clicks and stuff like that, but that's not the real value, right? So the real thing is about BOM inaccuracies, right? So there are business consequences to BOM inaccuracies, in addition to, and probably even more important than this, the little bit of saving time or a lot of it is saving time, but just saving engineers clicking time, right? That's not the big thing. It's really about BOM inaccuracies. Can you talk about that a little bit?
Yeah, I mean, the best way I like to describe this is like, it's actually, when you're talking about systems and large data pools, it's actually better to be consistently wrong than sporadically right.
Okay.
Okay.
So That makes
So the
sense.
idea that being like, you think about like, say all of my routings, I overestimate the time to make something by 20%. But as long as I'm consistently overestimating 20%, we can deal with that, because I could say,
Adjustment, yeah.
I can make a quick adjustment, right? And then like you think about all these systems and how they work, they're working off massive amounts of data. But if I have a like, well, sometimes it's 10% off, sometimes it's 10% low, sometimes it's 10% high, it's all over the place. Then it's really hard to work with, and you just basically have bad data. So like a lot of the thing about automation and integration, these types of things, is that when the software is doing it, it tends to be consistently wrong, which is actually manageable.
Right.
And that's something you can depend on that. It's just like in golf, if you always slice it, you just aim left if you're right-handed, right?
Yep.
So it's the same type of thing. So you're like, oh, okay, like, and you can work with that, and you can actually depend upon that in order to do more advanced things. So it's not, yeah, the data accuracy becomes huge, right? If I'm buying a $50,000 motor and I type 2 in instead of 1, that's a very costly mistake. But at the same time, that you have that kind of a very apparent, like very bad problem that everybody notices, but you also go back to the drift of like, I don't like, even if it's wrong, it's better, it's actually consistent. And the consistency is actually the most important thing, because then you can deal with something that's consistent. You just can't deal with anything that's sporadic, and you can't really depend on anything like that. It becomes unreliable. And that reliability of the system makes you believe in the ERP, makes you believe in all these things to actually run your business.
Right.
As opposed to being something that's kind of erratic.
I think that's a great word for today too. So reliability is definitely one of the most important pieces to anything that we're doing that deals with the BOM. Right. So let's move a little bit into the CADTALK software itself. Then, understanding what the BOMs are so important. Integration, is a big term. We see people throw that one around all the time. And so what makes CADTALK different from like a typical just integration tool? Because we know it's not just an integration tool, right? So what really makes it different?
Yeah, I think the biggest thing that like we deal with is that the engineering change process is actually the most complicated part of it. And we're really good at dealing with that, as well as like complex bill of material structures tend to be very complex. So if you think about integration, a lot of people think about like CRM integrations. It's like, oh, I have an address for this customer in this system, and I need to copy the address in the system over here. And it's like, and that's a fairly simple integration. You get like, lots of tools will do that, right?
Yeah, point to point, right?
Right, point to point, right? It's lots of things can do that. We like to just call ourselves more of an intelligent integration, because we're not really copying data per se. That's kind of a misconception. We can, it's a very easy thing to do. But we're actually creating what we call as a derivative. So what we're doing is, so like there's a term called ETL, extract, transform, load. But even beyond transform, like you're actually creating a derivative entity, like a derivative kind of artifact. So you think about what the engineer designs is called a engineering bill of material, or engineering design intent. And then what you have in the ERP, or the target system, we call it target ERP, is a manufacturing bill of material. And depending on your organization, they can be more or less similar, but they're always a derivative. The manufacturing bill of material is a derivative of the design intent.
Yeah, right? Kind of basic, right? Yeah.
It's a basis. And you mentioned this kind of earlier. It's like, I need a lot more data to actually make something than you actually gave me when you designed it.
Yep.
Right. And so people always ask us like, what's the master? I said, well, of what? The master of the design intent is the engineering system. The master of how we make it is the ERP system.
Yeah.
Because they're not talking about the same thing. One is a derivative of the other. Right.
Yeah.
And so CADTALK's job is to create that derivative, or get as close to creating that derivative as possible, and then allow a human in the loop to make the final decisions.
Yeah.
That's what it does different.
Dude, I like that a lot. So kind of adjacent to that, it does a lot, right? So as you said, there's some copy information, there's derive information, and that kind of thing. It's not just the materials that you're dealing with, right? It's the manufacturing piece as well, the BOM, the routing side of the bill of manufacturing. So why is it important to include those in when we're connecting the two? Why do we need to put the materials and the routings into the ERP system?
And a lot of companies don't. it depends on how they operate, right? There's some companies that just assemble things, and there's some that actually manufacture things and things like that. But but even then, if you want to have true costs, I mean, obviously, if you're purchasing everything, then you just get the purchase cost. But somebody's making it. Somewhere along the line, it's getting made by somebody. And we're finding more and more when you're starting to see, we're looking at trends of this, is that more and more there's a reshoring effort where like things are getting made more and more because of supply chain closer to where they're being consumed. So you're going to see like a lot more where people either they're going to have people they're working with directly, or they're going to have to supply how to make it, or they're going to see machining coming back into this factories more and more. So having those routing information is going to be more and more important. And we actually saw that decline for several lines because most of these were made overseas and they were outsourcing the manufacturing. Yeah. And so even a lot of our customers weren't pulling as much routing information as they used to, but we're seeing that actually go the other direction now. We're getting a lot more inquiries about how do I do these routings, because we're bringing those things back in to have more control over the supply chain. So that's usually where it makes the most sense, when you're actually doing when you're making your own things and putting them together. And even if you're just doing assembly, you need to know run times and how long it's going to take you to build it. So somewhere along the line, you need a routing. It's just at what level are you working at?
Yeah, for sure.
Yeah.
We're not building a space shuttle necessarily, but we might be putting a nut on a bolt and putting it in a bag. Those are two different places I have to do work or whatever. Okay, cool. Yeah. So when you were thinking about the design of CADTALK, and you had mentioned, from your history, it was like an engineer type situation, but really kind of an IT-ish job. Integrations typically fall into the IT bucket, where people say, oh, hey, come on, IT, come fix us, help us with this. But if I understand correctly, when you created CADTALK, you actually targeted engineers. Can you talk a little bit about that?
We actually targeted both. I mean, there was like different workflows. Like the workflow that we did, it's always engineers, but which type of engineer did we target? Okay. That's the better way to say it. Like there's two different kind of workflows we see. One is design engineers themselves, right? And then we also targeted manufacturing engineers, or people who understood the ERP side of the equation, right? So one of the things that we did, we actually did this, we had this idea of called hosts. So depending on which workflow you had, like if you were like the place I worked at where we had manufacturing engineers, they didn't have CAD always. They were actually working more on the ERP side. So we wanted to have the ability to consume the engineer's work. So a lot of our tools and stuff will read CAD files directly or connect right to their systems and pull data. And the reason we did that was because those guys who did that work knew how the ERP needed to be. So they can make decisions about routings. They can make decisions about what the ERP needed. But in some companies, the actual design engineers are the people who do that. They know what needs to happen. Yep. So our tool would also work inside of the CAD packages. And so that's why we made the tool be able to work whatever the package was or the tool was they used every day. And so it made sense, and it works for different workflows. And we even have a third version now, which is called a service host, which literally runs black box and there's nobody involved. It just does everything in the background.
Wow. Okay. So it does everything in a very, as you said, structured manner, right? So if we're missing consistently.
Yeah.
So that's interesting because there are sometimes when I'm dealing with manufacturing companies and their engineers, they'll complain even about our scheduling system because it's like, you're telling me I have to have a standardized way of doing this. And we actually need flexibility. And so CADTALK doing this, the BOM transformation, the creation, the derivative, that kind of thing. How do you balance that flexibility with standardization? Because standardization makes more sense to me. Let's do Lean, let's do Six Sigma, let's do that kind of thing. But sometimes there needs to be some flexibility. So how do you handle that?
Oh yeah, it's a great question. Like, so what we do is we actually, with the intelligent integration, we allow it to be configurable because like you said, we can't tell, like people have got a lot of history with what they've done in their designs and they've habits from the past. So we have to build in a certain amount of flexibility into how to be able to deal with data inconsistency, which is common. People are still designing the parts, and they don't do everything consistently as you like to. And then there's just all different kinds of workflows. So what we do is we actually have a configuration engine. Essentially like there's a way for us to do expressions, and it's very much like Excel. You can actually put rules in. There's a rules engine that runs inside the product that allows us to change it based on how you do things. and it has a lot of flexibility. Almost, some people would say too much flexibility, but like a lot of flexibility to do things. Just like ERP. I mean, think about like Sightline and what you can do to that. You can make it. It's so flexible. You can actually put a bad process in place. It's the same thing with CADTALK. You can do. So what we try to do is we have the flexibility built into the product, but we also match that with best practices. So one of the things is we don't actually have implementers. We have consultants.
Okay.
In the product, who basically they match best practices with the implementation. So that way they're like, hey, that way you don't automate a bad process, which is pretty common. Very similar to how SolutionsX implements ERP. It's like we're going to recommend the best practice along with the product, how we're going to implement it.
Yeah.
And if you don't do that, then you run into issues, right? So so that's the idea. Is like we want to come in and say, hey, you probably, yes, you have all these designs done this old way, but you probably should, put your raw material into this property, and then bind it to a feature in the model so the quantity comes out the way, and then we'll tie our quantity to that quantity. So when you stretch the model, the quantity changes, and they go, "Ooh, that's cool," and they start doing that.
Yeah.
Right, and then that process.
It's something they should have been doing all along.
Right. Yeah, that type of thing. Yeah. And so you're introducing best practices along with the implementation, and then their process improves. So you get the benefit of like, I got this really cool software doing these neat things, and I have this consulting to even do it better.
To help it out. Yeah, that's great. And for our listeners whose armpits started itching when Scott said it was very configurable, I want to be clear. The CADTALK software and the rules engine that you're talking about, that's not customizing the CADTALK software, right?
No. Everyone runs off the same software. It's usually just configuration within it. So it's like we don't create like custom versions for every customer. It's literally all of our, just like when I think Sightline has a similar thing where you create modifications in the product, but they still upgrade. It's the same thing. The changes that you do to make it work for your environment work with the upgrades. It's just we plan that in there. So
perfect. That's great. So talking about you can't have a podcast today. You can't advertise it on YouTube or put it on LinkedIn if it doesn't talk about AI. What do you, so without like two-part question again. So what does the future of engineering data look like over the next 5 to 10 years? And I think that's unfair. I think what does the future of engineering data look like over the next 3 to 5, maybe might even be a stretch. And then what role do you see AI playing in the CAD to ERP workflows?
Yeah, I think that, there's so many avenues where this is going to be a thing. It's like, I could just name a few like that, like was kind of like that whole suggestion thing I just talked to you about. So, and the consulting plus the implementation, that will become like get the best practices thing will become encapsulated into AI over time. Okay. And then it's literally customers can ask it like, how should I do this? And we'll be able to tell you and things like that. And then you'll be able to mold your process, with a consultant or through the AI. And then the fact that it configures itself to what you want, that will become part of the AI. The ones I think are really interesting is that job that I had years ago where somebody had to look at the parts and figure out how to route them. That will be automated by AI.
That's AI. Yeah, for sure.
Because it's a classic example. It's like I think about AI as an inference engine. Most of these LLMs and most of the machine learning models are inferencing engines. They're basically doing correlation. They're doing high level correlation. Yep. And I could say, we have lots of training data. I have all the routings in the ERP, and I have all the design data, and I correlate those two together, and and the AI get pretty good at predicting what routings should be there and what runtimes are going to be there. All those things happen, right?
This happens to me all the time. Somebody gives me a new use case for AI, and I go, "Holy cow!"
Yeah,
that's another one of those holy cow moments for sure.
Yep, there you go. And but you have to have that. We have to have access to both data sources, and we have that.
Yeah, for sure. Yeah.
So that's a neat one. And there's all kinds of things like that designs itself are going to be different. Like you're going to see AI generated designs. We're already seeing that. And then the other things I think you're going to leak into is like, how do you deal with changes, which I kind of alluded to earlier. It's like the original design isn't too hard, but like, how do I deal with the fact that I'm changing it and there's all this stuff happening? There's jobs in process, there's POs and out here, there's all these things happening. And how do I resolve all that? That's all manual today. But you're going to be able to do things like have it auto resolve, notify the vendors, pull the new things, all that stuff will happen. So this connective tissue between PLM and CAD and ERP, all that stuff there'll be AI between all these pieces doing that, orchestrating all of that in the future. And I think you'll also see supply chain things like where as engineers, like before, one of the classic examples I love is like the idea of like materials that alternate materials.
Okay.
So I design something, I say it's made out of like 304 stainless, and then there's like, and then our number 3 stainless, whatever that is. And then I'm like, well, I know I can substitute that with number 4 because number 4 stainless is polished on both sides, but like, that's really hard to do. But AI would be able to say, oh, I know that number 4 and number 3 are the same. I'm just gonna put that in the same nest, or I'm gonna sub that material out on the fly while we're supplying it, because I know I can get that because the other one's like an embargo somewhere.
Gotcha.
You got to see like that kind of predictive analysis and stuff you'll be able to do. So.
Yeah. So you're really kind of hitting the entire gamut of the AI experience right now, right? We're taking some data, we're going to augment some data using AI. We might even impact some data using AI agents and transact using agents. It's an exciting time. Manufacturing typically, Scott, runs a little slow, right? We're slow on the uptake for technology. Some of us are. Some are out on the bleeding edge, tip of the spear type stuff. But for those that lag a bit, we want to be careful that we don't let our competitors get this huge jumpstart advantage. We talk about it in the ERP space about moving to cloud and getting into the operating systems that have the AI and the agentic AI to help and that kind of thing. And if you're a manufacturer and you say, nope, I don't trust it, I'm staying on-prem, you just put yourself at least 5 years behind your competitors, right? So because they're in the cloud, they're leveraging all of this type of stuff. So from your perspective, knowing where we're going, we've got AI, machine learning, the agents, all that stuff. If you were a small manufacturer today and not quite ready to make this jump, what do you think I should be doing to prepare to be ready to make the jump? Is it a fair question? If it's not fair, we'll
Oh no. I mean, like as far as making the jump to AI, you mean things like that?
Yeah, and just making the jump into the future of these last few questions, just talking about AI and how it's going to impact the design, the integration, the BOM, all of that stuff is coming, and it's coming like fast. And so if you're not quite ready to adopt it, what should they be doing to prepare for it?
I mean, I think working with great partners to help you with that. I mean, like SolutionsX would be a great example of that, right? I mean, it's somebody who's going to help you along the way, or even like working with us. It's like, if you were wanting to prepare for that, it's like, it's hard. I think you have to first acknowledge that it's inevitable. It's like, and it's just right. I mean, change is inevitable. It's like we're going to get better at doing these things, and I think about I'm bald now. I can say this with confidence. I'm going to be 50 this year, and I've been through a few of these, right? And then what seems like cutting edge becomes mainstream very, very quickly, And like a lot of people, I had somebody I was working with, and they were like, well, "I'm not used to all this newfangled stuff." And I'm like I said, in 1999, going to a website was newfangled. I mean, it was like that's just and then it becomes like that's what you do, and so you just kind of move in that direction, but. And I think be open as far as being prepared for it, just like being open to the fact that that your business is going to change. It's like the way it works is going to change, and that it's equally scary, but equally a great opportunity at the same time.
We're seeing a lot of value, of value for people that are quote unquote early adopters. And I think we're about done with early adopters, right? I think now it's adopted. It's not even early anymore. Yeah. All right. So here it comes, brass tacks. If somebody listening walks away and remembers only one thing from our podcast today, what do you want that one thing to be?
That how important that especially if you're a manufacturer and you design stuff and you make it. I mean, how important that bill of material is to how your business runs. And it's like is probably the most central artifact of a manufacturing company is like literally the instructions for how to make your stuff. And like how you care for that. If you're going to invest in one area to get to get like huge leverage across all of your systems, making that bill right would be a good place to start.
Yeah, I agree wholeheartedly. So listeners, if your team is still manually entering BOMs, relying on spreadsheets, or struggling to connect engineering data with the ERP, reach out to SolutionsX to learn how CADTALK and ERP integration strategy can help streamline your operation from design to execution. Scott, thanks again for joining us today. And thank you to everyone listening to Boots on the Ground, where we talk about real systems, strategies, and people driving manufacturing forward. We'll see y'all next time.
Thank you.
Thank you for tuning in. If you've got questions or want to set up a free 30-minute consultation, visit our website or send us an email. And don't forget to like and subscribe so you never miss the latest ERP insights.